Hello there, my name is Jerne Joshinak and this is a quick introduction video on how to use machine learning for a simulator on the land support platform. So just briefly about the machine learning for a simulator, it's a completely new model which was developed in R and can be used to simulate forest growth based on forest inventory data, and of course then we have to select and modify different scenarios, and that's how we can assess the future states of forests based on our assumptions. So what we did in the scope of land support project is that we have simulated a variety of different possible, some more likely, some less likely scenarios for the future, and we have then extracted the growing stock. So this is the growing stock of trees per hectare, and also the basal area per hectare. So this is the in more general way of speaking, it's the amount of wood that can be expected on some particular place in time in the future. So machine learning for a simulator is available for Italy and for Slovenia. And before you start, you should select the area of interest. So now we will show you an example for Slovenia, and in this case we should first define our area of interest. And for example, we can to do so we have to first draw a polygon. So we click on draw polygon, and then in this case we will select the eastern part of Slovenia, and we simply make a polygon to the area which is in our interest. So let's go into the eastern part, and then when we are done, just double click, and then we make a name like East Slovenia, and then we submit this. And also now we have to save this polygon, clicking the save button, and again Slovenia East, for example. Okay, now we have successfully saved our polygon, which can be used to obtain the results from the machine learning for a simulator. Okay, so in the next step we navigate to the national scale tools. We select Slovenia, and now the platform is going to give us what are the available tools. And for Slovenia we have only machine learning for a simulator, which can be found under the supporting sustainable forestry. And after double clicking we get the following modeler requester. So we should select Slovenia East. This is the area which we defined. Now for Slovenia we have a 6-year step. So it starts in 2018 and then it goes by 6 years, because in Slovenia our national forest inventory is carried out every 6 years. So this is also the step for the future. Then we can select different harvesting rates. When we assume that foresters will harvest with higher intensity, then we should select higher rates like 90%. In other cases, when we assume that foresters is going to harvest only approximately 50% or 40%, then we have here the 40% of field harvesting. We have two different climate scenarios. So one assumes warmer climate, and the other one also warmer than today, but with less warming, so with a smaller warming rate. So let's select the RCP 4.5. We also have to select the mortality. Are we assuming maybe higher mortality because of the drought? It could be like 4%. And also the thinning, it's important because when foresters are focused on thinning rather than on final cut, the forest structure that it's at the end, it's of course different, because with the final cut the forest starts from the beginning, while with thinning we only take out certain amount of wood, and then what is left there, it's still yeah older forest. It doesn't start from the beginning, so let's say 40% of thinning. Okay, then click on evaluate, and on the right side the platform is going to retrieve the results. So we have to select the the forest simulation, which was just initialized, and with double click we get the details down there. So we have two result matrix, and we can first see the result matrix number one. We have here individual plots, so all the plots which fall inside our area of interest, and for each plot we get the growing stock, the basal area, and also the expected harvesting volume. So harvesting volume is in cubic meters per hectare per year. Okay, so here it's um, more detailed information. But what could be more interesting is the result matrix number two, which is actually a summary for all the plots. So we get the number of plots which are in this area. Then we also get the mean growing stock. So we also get the mean basal area, and also the mean harvesting volume per hectare per year in this period. So also we get other statistics like standard deviation, minimum, maximum, and other quantile ranges. Okay, so this is the first example which I show you, and for Slovenia. And then you can of course modify the area of interest. You can modify your assumptions. Maybe you assume higher mortality rates, maybe you assume lower mortality rates, and then of course you can study and you get information how these different inputs will affect the future states of forests. What you can also do is you can click this download button, which will export a table into Excel table into your download folder. So this can also be useful, and then you can use it maybe to compare different scenarios and different assumptions. Okay, and now we are also going to do one example for Italy. So everything is more or less the same. We first should define one area of interest for Italy, and maybe we can focus here on the in the northern part. So let's draw a polygon again. So we start here near Genoa, go close to the sea, and then we select this area, maybe Florence, and then the sea, and okay, with a double click we finish, and let's say Italy, maybe north, Italy north. Okay, and now we should also save this. So Italy north. Okay. Now we have to navigate to national tools. We this time select Italy. On the right side we get all available tools for Italy, which is we have different available tools, but machine learning forest simulator can be found under agriculture and forestry, supporting sustainable forestry. And now we click on the machine learning forest simulator. So the input parameters are slightly different. So we select the area of interest Italy North. The time step for Italian simulations is 10 years, because in Italy the forest inventory was done in 2005, and then in in the next repetition. It was 2015, so we might now access the result for 2035. Again, for the yield harvesting, we'll assume some middle option with 65%. In terms of climate, here we have SSP scenario, so let's select 2.5 245. In mortality, I expect it to be higher mortality in the future, and also for the thinning, maybe 40%. Okay, now we click evaluate, and on the right side we can see that the process is retrieving results, and now it's already finished. So again, we get result matrix number 1 and result matrix number 2. So in number 1 we get detailed results for each plot. So in this case we have higher number of plots because the dense forest inventory dense network is higher, so we have higher number of plots per square unit. We get information about the growing stock, the basal area, and also about the harvesting, which is assumed under these specific assumptions which we have selected at the beginning. Also, now we can see the result matrix number 2, where we get the summary for the area of selection. So in this case, we can see that the growing stock is expected to be a bit lower than in Slovenia, which is also usually the case, because since different types of forests here, we get the statistics, the quantiles for growing stock, basal area, and also for the harvested volume. Okay, so this was just a brief demonstration on how you can use machine learning forest simulator in the land support platform. I would say this is a very useful tool for policymakers, but also for researchers, and in some cases also for forest owners, which could have forests which with bigger area, and if they have at least some plots in their forest, they can define the area of interest only for their forest and obtain the results for their forests under different scenarios. So this could be very useful. Okay, so if there will be any questions, of course, you can always contact me. Otherwise, I wish you to have a nice to enjoy using machine learning forest simulator in the land support platform. Thank you very much.